So today what we'll be doing is we'll be taking a look at graphing from tables. Now, normally what you'll have is sometimes what I'll do is I'll give you an equation, y equals x squared minus 2. What you can do immediately is we can go and interchange y with f of x, so we can easily remember that this is a function. Now, in order to do our computations, we need to create a table of values. And we said that earlier, that parabolas could be computed from using tables or graphs and can be represented by equations. So let's do that right now. Let's go and set up our table. So our function is f of x is equal to x squared minus 2. And we'll set up our table. That's number 1. Now, if you take a look at this chart that I have on my right side that I basically given to all of you, basically I have values of -4 to +6. And this represents all the x values on my x-axis, right? And our y-axis. We'll talk about those later. Now, I'm going to choose to use -4 all the way up to +3. So you'll notice I have on my x-axis -4, -3, -2, 1, 0, 1, 2, 3, and 4. Now, I'm hoping that I'll be able to graph my function, my quadratic function, in this graph. So what we're going to do is we're going to do some computations, and those computations using this function f of x will give us the points for the graph, where x is our x value and f at x gives us our y value for our point. So let's start that with x is -4. And we're going to get -4, and we're just going to substitute -4 in for x squared. So I got -4 squared minus 2. Punching that into our calculators, I'm going to get 14. Now let's go to our next step. We're going to go and take a look at what happens if x is -3. And we get -3 squared minus 2. Punch that in our calculator, exactly as you see it with brackets, and you get 7. And we do this until we feel we have enough points. And just to make sure that we're following the steps. So now we've just gone from -4 all the way down to 0. So let's continue a little bit for a little bit farther. So we choose x is 1 and we plug in to our equation. 1 squared minus 2 gives us, well, -1. And then 2 squared minus 2 gives us 2. And then 3 is 3 squared minus 2 gives us 7. Now right now you'll notice that if you take a look at the y values on our chart, our y values start high and get lower and lower and lower until it reaches a minimum number of -2. When we have a minimum number of -2, a single minimum number of -2, or a maximum number of a certain value, then that is our vertex. So our vertex is going to be 0, -2. Now what I'd like you to do is I'd like you to plot the points. Pause the video and do so yourself. Now let's go through a few of the points together. Well, -4, 14 is way too high off of this graph, so it won't even show up on our graph. So let's go and take a look at -3. So -3 has a value of 7 for its y value, so its point is going to be at -3, and we're going to go up 7 to this specific point here. So I'll just plot that point. Now, for our next point, we're at -2, 2. So let's do that. Go from -2 on the x-axis up to +2. And we'll plot that. And we go through those steps, and we're going to get the following. Now, you'll notice the entire right side of my parabola has been created where we have our minimum point here. Now, remember I told you that there is an imaginary line here going through our vertex, our lowest point on our parabola. So that means all we have to do is, for this first point here that we have here, we can map it exactly 2 points over from the line of symmetry that occurs halfway through the parabola. So I'll do that quickly for the other sides. And now we graph our majestic curve, the majestic parabola. And make sure you always put on your graph arrows because it goes on forever. You must also label your graph. F of x is equal to x squared minus 2. You must also label your axes as x and y. So here is the x-axis, and here is the y-axis. And we are literally done. Now, you'll notice the lowest point on this graph is here, and we call that the vertex. Now, if you manage to figure out this column that we were doing here when you're computing your tables, what you need to do is, if you see two lowest or two highest points which are identical and side by side to each other, all you have to do is plot the points and then try to figure out where that lowest point is going to be. That lowest point would be between those two maximal or minimal points on your graph. You can talk to me about that in class if you'd like. The last thing that you should remember is the concepts of domain and range. When we take a look at this parabola, any parabola, the domain is always x such that x belongs to real numbers. You guys always call it XER. Now, as for the range is always dealing with our y values. So we have y such that now the problem is to determine what values y goes for. So if you look at this graph, if I was looking at this graph, it starts at the bottom and continues going up forever. So we have to figure out what its lowest y value is in this case. Because it's opening up, its lowest value is -2 for its y value. So we would write y is greater than or equal to -2. And y belongs to all real numbers for our final answer for the range. Now, if we had a parabola that was opening down, basically this portion here would help us figure out where our maximal value is, and we would have y being, instead of greater than or equal to negative something, maybe it would be y less than or equal to something, with y belonging to all real numbers. And there you go. Now your homework is in the weekend homework folder for October 6th. There are two files. One is called the quadratic function. Quadratic functions. And the second homework is 2.3, and it's called Homework for Quadratic Functions. Good luck, guys. Basically, that is your work for the weekend. So, for 2.3, do all the work that's in that package. It's fun. And then for 2.3, the homework, do the work that is indicated on the worksheets. Good luck, guys.